Hello students, how are you all? I hope that you all are good. As we know, the series of motion in a straight line is going on and we have successfully finished the 7 lectures, right? So in a previous lecture that we have discussed about applications of equations of motion and we have successfully discussed the two applications, right? So the velocity and the time taken by the object to reach half of the maximum height and the 3 by 4 of the maximum height. Okay, and at the end of the session we have solved some two previous year MSET examination questions, right? So the series is going on and this is a part 2 lecture on applications of equations of motion. Okay, right. So my name is Rakesh. Welcome to our beautiful physics channel, Rakesh sir Physics. Shall we start the session? Right. So what is the chapter going on? Motion in a straight line. Motion in a straight line. And this is a class number 08. Okay, right. What is the topic today? What is the topic today? Topic is what? Applications of equation of equations of motion. Okay, and we have successfully finished the two applications, and today we are going to discuss about application number 3, third application, application number 3. Okay, right, right. So have a look. So the application is what? Hmm, la 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 la. Hmm. Right. So this is our application. Okay. This is our application. So what is this, sir? Oh, you draw just one diagram and you are saying that this is our application. What is the meaning of this diagram? Have a look. An object is dropped. An object is dropped from certain height, certain height h. An object is dropped from certain height h. Okay, and at the same instant, at the same instant, another object is projected is projected vertically upward direction, vertically upward direction. Okay, so an object is dropped from certain height h. One object is dropped from certain height h, and at the same instant, one object is dropping from the certain height h. At the same instant, one more object is projected vertically in a upward direction at a same instant. Okay, same instant. At the same time, it is dropped. It is projected. So two times are same at the same instant. Okay. So first one, find the time. Find the time when the two objects are when the two objects are meet. When the two objects are meet. So we have to find this. What we have to find? We have to find the time. We have to find the time when the two objects are meet. Have a look. This is moving towards the ground and it is moving away from the ground. Okay. So at a particular instant of time, the two objects are meet. The two objects are meet each other. So at what time they are meet each other, we have to find. Are you getting? Solution. Right. So an object is dropped from certain height h. One object is dropped from certain height h. Okay, have a look. This is the ground. and here an object is dropped. Okay, this is height h. Right. So as we know, whenever the object is moving towards the ground from certain height, whenever the object is dropped from certain height, okay. So the initial velocity of the object is zero. The initial velocity of the object is zero, and it has some final velocity, that is v, and the acceleration due to gravity a is equals to plus g, because it is moving towards the ground. Okay. Let us consider in a time t, the object is moving towards the ground. The object is moving towards the ground, and it covers in a time t, it covers the distance s1 is equals to h1. Okay, and just drop the object from certain height, and in a given time t, it covers some distance, that is s1 is equals to h1. It covers the distance is how much? h1. Okay, s1 is equals to h1. So this much of distance the object is covered. So we have projected one more object from the ground at the same instant of time. At the same instant of time. Here these two t's are same at the same instant of time. Okay. Now whenever we are projected an object in a vertically upward direction, it has some initial velocity, that is u, and acceleration due to gravity a is equals to minus g, because it is moving upward, and acceleration due to gravity acts in a downward direction. Given particular instant of time t, the distance covered by the object or the displacement of the object, let us say s2, let us say s2 be the distance covered by the object in a particular instant of time, that is how much? h2. So I am taking the h2 is what? The distance covered by the upward projected body. Okay, so the total height is how much? H. The total height is how much? H. This is equal to the distance covered by the first object. Let us say this is first object. The distance covered by the first object is how much? h1, plus the distance covered by the upward projected body. The distance covered by the upward projected body or second body is equals to how much? h2. Is equals to how much? h2. Then h is equals to h1 is nothing but what? Displacement according to second equation of motion. So what is the second equation of motion? S is equals to ut plus half at square. So here distance or displacement is equals to h1. So in case of h1, okay. So in case of h1, this is equals to, have a look. In case of h1, the initial velocity of the object is 0 plus half a is equals to how much? Plus g, and the time is what? T square. Okay, and in case of second body, h2 is equals to what? Ut plus half at square. Okay, so h2 is equals to initial velocity of the object is u, the instant of time t is same, acceleration due to its gravity is minus half gt square. So h1 is equals to how much? Half gt square. h2 is equals to how much? Ut minus half gt square. Just substitute these values here. So h1 is equals to how much? Half gt square, plus h2 is equals to how much? Ut minus half gt square. Ut minus half gt square. So minus half gt square plus half gt square gets cancelled out, and we got a h is equals to ut. H is equals to ut. What we have to find? We have to find the time when the two objects are made. Just to write the equation for time. So that is equals to h by u. So at this time, the two objects are meet each other. Okay, time t is equals to how much? H by u. Okay, so whenever the object is dropped from certain height h, at the same instant, one more object is projected vertically upward direction from the ground. Okay, so the time taken by the two objects are meet. The time taken to meet the two objects is given by t is equals to h by u. Where, so what is h? Where h is nothing but what? Height from where we are dropped the object. What is u? Initial velocity of the object with which we are projected an object. Okay, so by using this equation we can find when the two objects are meet each other. Okay, right. So let us see the second one. So the second one is find a time, find a time when the two objects are, when the two velocities of, when the two velocities of objects are equal. Objects are equal. So what they are asking, find the time when the two velocities of objects are equal. So have a look. This object is moving with certain velocity and this object is also moving with certain velocity. So at what time the two velocities of the objects are become same, we have to find. Okay, right. So in case of first body, in case of first body or first object. So what is first object? This is our first object. Have a look. It is moving towards the ground. It is a freely falling body. So in a first case, initial velocity is equals to 0. Acceleration due to gravity plus g. Okay. And time taken t is equals to t. T is equals to how much? T. In case of second body, in case of second body, so it has an initial velocity u is equals to u. It is what? Upward projected body. Upward projected. So acceleration due to gravity minus g because it is moving away from the ground, and it has a final velocity. Maximum height. The final velocity of the upward projected body is 0. But we are talking about what? The two velocities of the objects are equal. That means somewhere in this journey it is moving towards the ground and it is moving away from the ground. In this journey, before reaching to the maximum height, before reaching to the maximum height, somewhere the two velocities of the objects are equal. Somewhere the two velocities of the objects are equal. That's why I'm taking the final velocity of this object as v. Final velocity of this object as v. Okay, I'm not talking about maximum height. It is clear, right? So in case of first body, I'm taking the first equation of motion, that is v is equals to u plus at. V is equals to how much? U plus at. So the final velocity of the object, let us say v1. Let us say v1. So which is equals to u. Initial velocity of the object is 0. Acceleration due to gravity is g. And the time taken by the object, let us say t. So we got v1 is equals to gt. v1 is equals to how much? Gt. Okay. So if it comes to this body, second one. So same equation. So let us consider v is equals to v2, final velocity. So v is equals to u plus at. Okay. So v is equals to how much? v2. That is equals. What is the value of initial velocity? U. Acceleration due to gravity minus g. And let us say time taken by the object is t. T be the time taken by the object. So according to given question, so what they are asking, find the time when the two velocities of the bodies are same. Okay, the two velocities of the objects are same. Two velocities are same. That means v1 is equals to v2. v1 is equals to v2. Okay, so what is the value of v1? gt. This is equals to, what is the value of v2? U minus gt. Okay, so bring this gt to this side, then it becomes u is equals to gt plus gt. Then u is equals to 2gt. What we have to find? We have to find time. We have to find what? Time when the two velocities of the objects are same. So we got t is equals to how much? U by 2g seconds. So at this time, the two velocities of the objects are same. The two velocities of the objects becomes same. Are you getting? Any doubts? Right. So pause the video and write the notes. Okay, 3, 2, 1, go. Right. So it is clear from that concept. So what is that? So the time when the two objects are meet, when the two objects are meet, so they meet, t is equals to h by u. T is equals to what? H by u. Okay. And one more formula we got. What is that? When the two velocities, when the two velocities of the objects are equal. So we got t is equals to how much? U by 2g. T is equals to u by 2g. Okay. So let us see one example problem. Okay, have a look. So the example is right, height of this building, let us say h is equals to 300 meters. Okay, h is equals to 300 meters. So an object is dropped from the height h is equals to 300 meters of the building towards the ground. Okay, at the same instant At the same instant, one more object is projected in a vertically upward direction with the initial velocity 100 meter per second. With initial velocity 100 meter per second. Right. Find the time when the two objects are meet. When the two objects are meet. Okay. So the second question. Find the time when the two velocities of the objects is same is same. And the third question, find the distance where the two objects are meet. Find the distance where the two objects are meet. Okay, so pause the video and try the solutions for these three questions. 3, 2, 1, go. Pause the video and try the solution. Okay, 3, 2, 1, go. Right, let us come to first one. So the time, find the time when the two objects are meet. So we have the formula. What is that? T is equals to h by u. What is the height of the building? 300 meters divided by u, initial velocity of the upward projected body. How much? 100. So two zeros cancel out, is equals to 3 seconds. Okay. So at the 3 seconds, these two objects are meet. So find the time when two velocities of the objects are same. When the two velocities of the objects are same. So we have the formula. What is that? T is equals to solution. T is equals to how much? U by 2g. So what is the value of u? 100 divided by 2 into g means what? Acceleration due to gravity. Its value is how much? If you can take a 9.8 or 10. Both are gives nearly same answer. I am taking the 10. Okay. So g is equals to how much? 10 meter per second square. Okay. Right. So 1010 cancel. 2 ones are 2 5s are. So t is equals to how much? 5 seconds. So after 5 seconds, the two velocities of the objects becomes same. Excuse me. After t is equals to 5 seconds, the two velocities of the objects becomes same. So what is the third question? Find the distance where the two objects are meet. Find the distance where the two objects are meet. So how can we solve? Have a look. We know the time. Okay now. So we know about the time where the two objects are meet. So at what time the two objects are meet? So t1 is equals to how much? 3 seconds. T is equals to how much? 3 seconds. Okay. So we know the initial velocity of this object. So what is that? U is equals to 100 meter per second. Okay. So whenever the object is moving away from the ground, its acceleration due to gravity A is equals to how much? Minus g. Okay. So what we have to find? Distance S is equals to how much? Right. So we have the second equation of motion. So what is the second equation of motion? S is equals to ut plus half at square. Okay. We have to find what is u? 100 and what is t? 3 plus a is equals to minus g. I am taking a plus into minus minus half. What is the value of g? 10 meter per second square. And what is the time? 3 square. Okay, time t is equals to 3 square. Okay, so 2 ones are 2, 2 5s are 10. So s is equals to 3 into 100, 300 minus 5 into 3 square value. How much? 9. So s is equals to 300 minus 9 5s are 45. So s is equals to, we got a 255 meters. Okay, s is equals to how much? 255 meters. That means from the ground, the two objects are made at a t is equals to 3 seconds at a distance 255 meters from the ground. Is it clear? Any doubt? Right. Pause the video. Write the solution. So if you want to find out in this object, you will get the same distance. Okay now. So for this object also, you will get the same distance. Have a look. So in case of this object, okay, now freely falling object, initial velocity 0. It has a final velocity v. Okay, so time taken t is equals to, let us say, t 3 seconds. Okay, t is equals to how much? 3 seconds. So we have the equation of motion for final velocity. V is equals to u plus at. So u value is 0. Then v is equals to a value is how much? 10 into 3. So v is equals to 30 meter per second. Okay, so the velocity of the object is how much? 30 meter per second at a time t is equals to 3 seconds. Now we have to find the displacement. So displacement s is equals to what? So I am using this equation, that is v square minus u square is equals to 2as. Okay, so initial velocity is 0 and v square is equals to 2 into a into s. So v square, what is the value of v? 30 into 30. Here we got v is equals to 30 now. So v square is equals to 30 into 30. This is equals to 2 into acceleration value is how much? 10 into s. So 1 0 1 0 cancel out. 2 1s are 2 15s are 15 3s are 45. S is equals to how much? 45 meters. So we got s is equals to 45 meters. That means this object meet, this object at a 45 meters. At what distance? 45 meters. This object meet this object at a 45 meters. And this object meet this object at a 255 meters. Okay. This object meet this object at a 255 meters. And this object meet this object at a 45 meters. Just add these two distances. 255 plus 45. How much? 300. Are you getting? Let's pause the video and write the solution. 3, 2, 1, go. Right. So let us see the one more example question. Second example, and this is a MSET question. Okay, TS EAM CET 2018, I think 2018 year question. So in this question, they are given the data like this. Have a look. Okay. This is a height of the building. H is equals to 60 meters. H is equals to how much? 60 meters. Okay, right. A ball is dropped from the height h is equals to 60 meters towards the ground. At the same instant, one more object is projected in a vertically upward direction with the initial velocity u. With the initial velocity u. Now, these two objects are meet at a height of 2h by 3 from the ground. 2h by 3 height from the ground. Find out initial velocity of the object. So they are dropped one object from h is equals to 60 meters height and the object is moving. At the same instant, one more object is projected in upward direction. Now the two objects are moving like this. Okay. So from the ground at a height h is equals to 2h by 3. From the ground at a height h is equals to 2h by 3. The two objects are made. So what they are asking? Find the initial velocity of the body. Find the initial velocity of upward projected body. So pause the video and try the solution. 3, 2, 1, go. So have a look the solution. Right. So one thing it is clear that from the given question, this object meet this object at a height of 2h by 3. So because from the ground these two objects are meet at a height 2h by 3. Is it clear? Let us consider this is a first body and the height of this body, let us say h1. H1 is the height traveled by this body in upward direction. Okay. So h1 is equals to, what is the height traveled by this body from the ground? 2h by 3. 2h by 3. So 2 into what is height? H is equals to how much? 60 meters. H is equals to how much? 60 meters divided by 3. This equals to 3 ones are 3 20s are. So 2 2s are 40. H1 is equals to how much? 40 meters. That means from the ground, these two objects are meet at a height of 40 meters. Height at what? 40 meters they meet. Okay. So if this is 40 and the total height is 60, this is 40 and this is 60, then what is the distance traveled by the second body? 60 minus 40, that is how much? 20 meters. So 20 meters is the distance traveled by the first body. It is traveled 20 meters and it is traveled 40 meters. They are meet each other. Now what we have to find? Initial velocity of the object we have to find. Have a look. At this height, the two objects are meet. At this height, the two objects are meet. This second object is moved 20 meters and it is made the first object and it is made the first object. Okay. So let us we take a second object. So this is what second object, and the initial velocity of the second object is equals to how much? 0. Okay. So and the distance traveled by the second object, let us say s2 is equals to h2 is equals to how much? The distance traveled by the second object is how much? 20 meters. Okay, 20 meters. And acceleration due to gravity, whenever this object is moving towards the ground, acceleration due to gravity is equals to g and its value is how much? 10 meter per second square. Okay, and I want to find time. I want to find time. Have a look. This time gives the time taken by the second object to travel 20 meters distance. Okay, so the time taken by the second object to travel 20 meters. If it travels 20 meters in a time t, in this time t, these two objects are made. The two objects are made. And in a previous question, in a previous application, we have solved that t is equals to h by u. T is equals to h by u. What is h? H is nothing but height of the building, that is 60. Okay, divided by u means what? Initial velocity of the object we have to find. T means what? The time when the two objects are made. If you find this time, what is this time? At a time t, the second object travels 20 meters distance. At 20 meters distance from this height, if it is traveled 20 meters distance, at 20 meters distance, the two objects are made. At 20 meters distance, the two objects are made. This time gives what? When the two objects are made. So we have the formula. If the two objects are made, if the two objects are made at a time this, we are having the h value, we are having the time value, we are finding the time value from this, and if we substitute these two, then we can find u easily. Are you getting? Concept is clear? Right. So I'm taking the equation of motion s is equals to ut plus half at square. Okay, what is s? 20 is equals to initial velocity is 0, 0 into something 0, half into a is equals to how much? 10 into t, we have to find the t square. 2 ones are 2 5s are 5 ones are 5 fours are. So t square is equals to 4, then t is equals to 2 seconds. So just substitute t is equals to 2 seconds here. Okay, so 2 ones are 2 30s are u into 1, u is equals to 30 meter per second. So the initial velocity of this object is how much? 30 meter per second. Are you getting? Any doubts? Well, so pause the video and write the solution. 3, 2, 1, go. Right. So this is the end of the today's lecture, and this is the small concept. Okay. So we have a previous year problems on this concept. That's why I'm explaining. I hope that you have enjoyed this lecture and you have understood this lecture. Okay. So the time taken by the two objects projected. So one is projected vertically upward direction and one is freely falling body. So at what time they are meet? T is equals to h by u. T is equals to h by u. So at what time the velocities of the two objects are becomes the same? T is equals to u by 2g. T is equals to u by 2g. Okay. If you want to find the distance from the ground, use s is equals to ut plus half at square. Or if you want to find the distance from height h, you can use v square minus u square is equals to 2as formula. You will get the distance where the two objects are made from the ground or from certain height. Okay. So this is what? This is a one previous year question. So, right. This is the end of the today's session. We will meet on a next lecture. Until then, stay tuned. And this is Rakesh signing off. Jai Hind.